What's up, guys? Coach Tugger here. Hope you guys haven't missed me too much while I'm gone. Hope school's still going okay. Thought I'd jump on here and make a video about a couple of the things that you should be working on though. You should be in Quadratics. Should be finishing taking your factoring test soon if you haven't already. Hopefully I went enough with you with that. If not, when I go into Quadratics later, hopefully I can keep making some more videos and we'll have some more practice with it then. But I did want to jump into some of this stuff, so we're going to go down here. I've already went into Algebra 1. I've already pulled it up from the My Courses part. We're going to go down here to Quadratics. This is the thing I told you that I wish I could have got there, but I didn't. Click into it. Let me say this. This stuff right here. Go watch that video. It's 8 minutes long. I know, it's one of his longest videos. Go watch it. It's actually going to help you, okay? And then go through the intro. It talks a lot about opening up, opening down. What is the vertex? What are x-intercepts, y-intercepts? How can you find the axis of symmetry? And I'll talk a little bit as we go through too. But go watch that video. It's actually really good. And it's very informative, okay? We'll even talk about why it's called a parabola. So we're going to jump here to quadratic factored forms. So already we're in factored form. We have factored out the quadratic. And I mentioned this a little bit before I left with the zero product property. So the zero product property is, and let me blow this up a little bit more. Let me see if I can't do this. That's a little better. Maybe you can see that a little better. But zero product property. Basically, so if I pull up my writing tablet here. So the zero product property basically states that if, whoop, come on, there we go. If A, let's try that again. A times B is equal to 0. Well, then it must be true that one of the two must be 0. So A must equal 0 or B must equal 0. And if you think about that, makes sense, right? So if you got two things that are being multiplied times each other equals 0. The only way you're going to get that is equal to 0. Well, compare that to what you have here. You have x plus 1 times 3x plus 4 is equal to 0. Then one of those two has to be 0. Either one of them could be 0. So you set each one equal to 0. We have x plus 1 equal to 0. You also have 3x plus 4 equal to 0. So solve each one. Subtract 1 on each side over here. So x equals -1. Subtract 4 over there. Those cancel, leaving 3x equals -4. Divide by 3, divide by 3. So x equals -4 over 3. By the way, don't make fun of my handwriting. I'm still learning this tablet. So we're talking about for the x's here. So I'm going to now click off this so we can type in -4/3 and -1. -4/3 is the smaller x because it's further left on the number line. So -4/3 and -1. And there we go. I'll do one more of these before I move on. So we have g of x is equal to x minus 2 times 3x plus 3. Again, zero product property states that since the product of these two must equal 0, then set each one equal to 0. So we have x minus 2 is equal to 0. We have 3x plus 3 equals 0. Boy, this thing is really hard to write. All right, just as good as I do on a whiteboard. So add 2 on each side here. So x equals 2, because those cancel. Subtract 3 on both sides over here. Those cancel, leaving 3x equals -3. Divide by 3 on both sides. So x equals -1. So we have our two answers, -1 and 2. Again, make sure you type it in correctly. So -1 is going to go first. So -1 and then 2. All right, and there we go. Let's move on to the next one a little bit. And again, you can pause this video if you need to move a little slower. So what is the vertex of the parabola? Well, if you remember the vertex, he talked about this earlier in the video. The vertex is the highest or lowest point on a parabola. And the easiest way to find your vertex is if you know your two x-intercepts. First off, if it's just one x-intercept, right? One x-intercept, you got it. It's right there. That's the x-coordinate. But in all these, they're going to give you two x-intercepts. So that means both of these can be set equal to 0. Then if you got two x-intercepts, so if I'm looking at this on a graph here, so I'll pull it up real quickly. So if I have two x-intercepts on this graph, and it's like that, then it needs to be the halfway distance between these two, whatever that distance is. So that's the x value. The x value would be in between the two. So then in order to find the y value, you just plug it back in. So let's go through and I'll show you what I'm talking about. Let's do a little math here. This thing's kind of cool. I'm not going to lie. All right, so quit. Okay, so we have y is equal to x minus 5 times x plus 1. We need to use the zero product property first. So we have 0 is equal to x minus 5 times x plus 1. We need to solve for 0 for each one of these. So x minus 5 is equal to 0. X plus 1 is equal to 0. So obviously x equals 5. And x equals -1. So think about what that means. If I drew a graph over here real quickly on the left side of the screen over here. Come on, right there. And if x was at -1 here, and at 1, 2, 3, 4, 5, we'll say 5 there, okay? And let's say we had something like this. And let's say our graph is going to look something like that, okay? Oh, that's terrible. But go with it, go with it, go with it, okay? If that's what our graph looks like, the x-coordinate of the vertex is always halfway between the two x-intercepts. It's always halfway between them. So, if I look halfway between these two, what is that? Well, the easiest way to do this, in all honesty, is just to add them and divide by 2. That's really the easier way. That's the little secret way to do it. So 5 plus a -1 divided by 2 is 4 divided by 2, which is 2. And if you think about it, if this is 2 right here, yep, that's going to be the midways. It's 3 to get there. It's 3 to get there. So, yep, 2 is in between the two. So what is the vertex? Well, x is 2. So what's the y value? Well, in order to find it, plug it back in. So you have 2 minus 5 times 2 plus 1. And if you do this correct, watch what happens here. It's -3 times 3, which is -9. But you notice it's the same distances. Again, no negative number here is because it's a negative direction. Remember that. But -9, so 2, -9 would be our answer. By the way, all of these will probably be opening up. That's why you're going to get positive values here. So let's get out of this. Let's type. So 2, -9, don't forget that. I would 2, -9. We'll do one more real quickly. We'll work this one a lot faster, and here we go already. Y equals x minus 2 times x minus 6. So let's go ahead and work the zero product property on this. So we have 0 is equal to x minus 2 times x minus 6. So as x minus 2 equals 0, x minus 6 equals 0. So obviously x equals 2. And x equals 6. So I know that's my two x values, so obviously it's going to be on this line and this line. What's halfway between them? Well, it's 4, because 2 plus 6 over 2 is 8 over 2, which is 4. So the 4 is the x value of the vertex. What's the y value? We plug it in. So 4 minus 2 times 4 minus 6, that's 2. Times a -2, you're going to notice that little pattern happens each time. That's a -4. So 4, -4 is the vertex. And when I graph it, I need to make sure I include one of those x coordinates, or one of the x intercepts. So let's go do that. It's 4, -4 is one of them. So 4, -4. So 4, -4. And the other x value is 6. And again, check it again real quickly. Remember, the other x-intercept should be 2, and we verify that by checking here. Yep, it is 2. We're good. 4, -4, and we're good. Any questions? Wonderful. Boy, I feel like I'm teaching because I'm talking to a video and I ask any questions. Let's move on. How long? Let's go about 5 more minutes in this video, then I'd be plenty length. This is already long. So it says now graph the equation. So this one's going to be a little different, but not a terrible amount. So the first thing we're going to do is we're going to just graph it. So let's stay right there. That way I can actually utilize the graph in a minute. All right. So we have y is equal to we have y is equal to 4 times x plus 6 times x plus 4. We're going to use the zero product property. So 0 equals 4 times x plus 6 times x plus 4. And now zero product property states that we set each one of these equal to 0. Well, now, this 4 is being multiplied times all this stuff. So technically, we could do this and then recognize, yeah, that's not equal, so 4 is not one of them. We have x plus 6 equals 0. X plus 4 equals 0. So x must equal negative 6. That's a negative there. And x must equal negative 4. So those are the two x-intercepts of this parabola. So if I was graphing it without looking at that right now, it's a negative 4 and negative 6 here. So obviously, what's my vertex? Well, the vertex is in between them. So I know it's going to be negative 5 as the x value of my vertex, the x coordinate. I also know that because negative 6 plus negative 4 over 2 is equal to negative 10 over 2, which is negative 5. So negative 5 is the x value of this. But now we need to plug in negative 2 in. So if you plug that negative 2 in, so negative 2 plus 6 times negative 2 plus 4, and then you have the 4 out here. Work that out. This is a positive 4. You should plug in negative 5. I'm sorry. I was wondering why that wouldn't work out right. Let's erase that. Just erase it. That should be negative 5 in there because we're plugging in the x value. So 4 times negative 5 plus 6. Again, I used that pattern to make sure I was doing it correctly. That's why whenever I stopped, I was like, wait, those aren't the same. This is a 1. Obviously, that's a negative 1. And that's a 4. So 4 times 1 is 4, times negative 1 is negative 4. So it's not 1, 2, 3. Yep, it is right there. So there's my points, and my parabola will look something like this right here. It's going to be a super steep parabola. It's going to go up quick. So just remember that's what it looks like. We'll plug it in. It's going to obviously look 5 billion times better when we use the software. So we had at 5, negative 4. One of the x-intercepts is negative 4. And again, negative 6. We check it, and we're good. We'll do one more. Do one more real quick like here. This is a good one. This is one that people would whine. Oh, it's too hard. No, it's not. It's pretty easy. Pretty easy. Now, if you remember, if you watch that video, if you remember, some parabolas will open down. Well, you know this will open down because of that number right there. You see that negative in front? That negative in front, anytime the leading a, the a value, remember ax squared plus bx plus c. Anytime a is negative, it's going to go down. So it's going to go down, okay, open down. So we're still going to set this equal to 0. So we got to use our zero product property, negative 2/3 times x plus 1 times x minus 5. So we set each thing equal to 0, negative 2/3 set equal to 0 doesn't work. X plus 1 equals 0, x minus 5 equals 0. So that's x equals negative 1. And x equals 5. Well, what has to be in between those? Well, if you're looking at negative 1 and 5, obviously 2 is right in the middle. We did this one earlier. So I know the x value of the vertex is 2. So I'm going to write it like this time so you can sometimes see it differently. So the x value is 2. I know that. Well, what's the y value? Well, if you plug in 2 here, 2 plus 1 times 2 minus 5, that is 3 times a negative 3. Now notice we still have our negative and positive here, and that's the pattern we want. That's good. That's negative 9. But it's negative 9 times negative 2/3. I'm going to write this over to the side so the graph doesn't get in the way. Well, again, notice what's a negative times a negative? It's a positive, so you know your value is positive. 3 goes into 9 3 times. 3 times 2 is 6. So the y value is 6. So it's going to be here. So this graph opens down. Its vertex being at 2, 6. It looks something like that. Oh, wow, that was terrible. By the way, I now know why he can't draw on this. This stuff is kind of hard. There we go. It's going to look like that. We said 2, 6, right? And it went across a negative 1. There it is. All right, let's do one more real quickly, and then we're going to be done. hopefully this gets you started